Hello everyone. In this video, we are looking at GCF and LCM of two integers. GCF stands for greatest common factor. LCM stands for least common multiple. What is a factor? What is a multiple? Let's say we have a 15 equals 3 times 5. Then we say 3 is a factor of 15 because 3 goes into 15 5 times. And 15 is a multiple of 3. 5 is also a factor of 15 because 15 divisible by 5. 5 goes into 15 3 times. We can find other factors for 15. For example, 1 and 15. 15 is divisible by 1, so 1 is a factor of 15. Number 1 actually is a factor for any integers. 15 itself also a factor of 15 because 15 goes into 15 one time. So this is the concept of factor and multiple. Let's see what is a prime number. What's the definition of a prime number? A prime number is a whole number bigger than 1 and only has two different factors, 1 and itself. We have a 1 through 20, the first 20 natural numbers. We are going to use the definition here to determine which of them are prime, which of them are not. A number, a positive integer, which is not a prime, is called a composite. But here we focus on prime. What is a prime number? From the definition, actually, we know 1 is not a prime number. More specific, why? How come 1 is not a prime number? Because 1 is only have one factor, is itself, right? By the definition, a prime number needs to have two different factors, 1 and itself. For number 1, 1 and itself are the same, so 1 is not a prime number. And let's look at the number 2. Is 2 a prime number? Let's find all the factors for 2. We have 1, we have 2, not anything else. By the definition, 2 has two different factors, 1 and itself. That makes 2 a prime number. In fact, 2 is the smallest prime number and also the only even prime number. Only even prime number. That means other even numbers are not prime. This one is not. Those numbers are not a prime number because, for example, 4, besides 1 and itself, it has the third factor 2. Even numbers are numbers divisible by 2. So those even numbers have a factor which is 2. 6 is the same. It has a factor 1 and itself. Besides 1 itself, it has 2 as a factor. Actually, 3 is also a factor. So it has more than 2 factors. That disqualifies 6 as a prime number. Other even numbers, they are all composite. What about 3? Is 3 a prime number? 5, 7. 9 is not a prime number because 9 has factors 1, 3, and 9. 11, yes. 13. 15 is not. Earlier I have shown you 15 has 4 factors, 1, 3, 5, and 15. 17 is a prime number. 19 is a prime number. So those numbers I bubbled are the prime numbers from 1 to 20. I hope you please remember those prime numbers. Example 1. We are going to see how do we prime factor a given integer. Prime factor a given integer. I'm going to explain what is a prime factor, what is a prime factorization. We're going to introduce a technique here. I use big L. When we need to prime factor an integer, we put the integer on the big L. And then we observe this number. Determine is this number an even number or odd number. 30 here is even. Even number we know is divisible by 2. So it has a factor 2. 2 is a factor of 30. 2 is a prime. So 2 is a prime factor of 30. Divided 30 by 2, we have 15. We write a quotient right below the big L. If 15, we know 15 is not a prime, so we put a 15 on another big L. Anyone can tell me a prime factor for 15? We know 3. 15 is divisible by 3, so 3 is a prime factor. 3 is a factor of 15. 3 is a prime number, so 3 is a prime factor of 15. Divide 15 by 3, we have 5. 5 is a prime. When you see a prime number on the bottom of the diagram, then we finish the procedure. How do we interpret this diagram? We have 30. We actually found all the prime factors for 30. 30 can be written as the product of 2, 3, and 5. This equation is called the prime factorization. Of 30. Here the integer is 30. In the product, we have 3 factors for 30, 2, 3, and 5. And all of them are prime numbers. So this factorization is a prime factorization of the integer. Let's see number 2. We are going to use the same technique to prime factor number 36. We put a 36 on a big L. 36 is an even number, so divide by 2. We have 18. 18 is even again, divide by 2. We have 9. 9 is divisible by 3. 3 is a prime. Divide 9 by 3, you have 3. 3 is a prime, so we finish this diagram. We interpret this diagram as 36 equals 2 times 2 times 3 times 3. By the way, the order of the factors in the product doesn't matter. I mean, if you write 36 as 3 times 3 times 2 times 2, or 3 times 2 times 3 times 2, they are all the same. The order of the factors in a product doesn't matter. So this equation is the prime factorization of integer 36. That's how do we prime factor an integer. And what is a prime factorization of an integer? We have a very important technique here, is the big L. Use the big L to prime factor an integer. Example 2. The reason we learn the technique from example 1 because we're gonna apply that technique to find the GCF for 2 given integers. Example 2, we are going to look for the GCF, the greatest common factor of 30 and 36. I have a 3-step procedure for that. Step 1, prime factor both integers. Prime factor both integers. We have done that from in example 1. So we have 30 equals 2 times 3 times 5. We have 36 equals 2 times 2 times 3 times 3. We put them vertically, one on the top, one on the bottom. Step 2, we are going to bubble common factors, common prime factors. So look at the right-hand side of the equations. The right-hand side of the equations are the prime factorization of the two integers, right? You can see that 2 is a common factor of the two integers. 3 is also a common factor, and only the two integers, not anything else. So that's step 2, very simple. Bubble the common factors. Step 3, take the product or multiply the common factors that you found in step 1, in step 2. So you can make a conclusion. GCF of 30 and 36 equals 2 times 3. 2 is in the first bubble. 3 is in the second bubble, right? Those are the two integers, two common factors you found for the two integers, 30 and 36. You multiply them together, you got 6. So that's how do we find the GCF for two given integers. Sometimes, maybe some of you are able to find the GCF just by looking at the two integers. But I strongly recommend you learn this procedure, the 3-step procedure. The procedure applies to any pair of integers, even the number is very big. As long as you follow the 3 steps, you could always find the correct GCF for the two integers. Example 3, we're going to look at two problems. Number 1, find the GCF for 10 and 30. Number 2, find the GCF for 4 and 7. For 10 and 30, you can pause here and try to apply the 3-step procedure to find the GCF. And your answer supposed to be 10. And this case actually is a special case. I name it as special case number 1. What is a special case number 1? When you need to find the GCF for two integers, of course, two numbers, one must be smaller, the other must be bigger. If the smaller number is a factor of the bigger number, in other words, the bigger number is a multiple of the smaller number, then that is a special case number 1. In special case number 1, GCF is the smaller number. So the GCF of 10 and 30 is 10. 10 and 30, 10 is a factor of 30. 30 is a multiple of 10. So GCF is the smaller number 10. Let me explain why. Because 10 is the biggest factor of itself. 10 is also a factor of 30. That makes 10 the biggest common factor of the two numbers. Let me write down what is special case number 1. Is one number is a factor of the other. So later when you see two numbers that they are special case number 1, then you can just find the GCF in 1 second. For example, 12 and 144. We know 12 is a factor of 144. 144 is a multiple of 12. So the GCF of the two numbers is the small number 12. For another example, 9 and 90. 9 and 90. 9 is a factor of 90. 90 is a multiple of 9. Is special case number 1. So the GCF is the smaller number. It's pretty convenient if you know this fact. Number 2, we need to find the GCF of 4 and 7. So you should you can pause here. You can pause the video here and use my 3-step procedure to find the GCF for 4 and 7. We can do it quickly here. 4 is 2 times 2. 7 in itself is a prime, so 7 equals 7. When you look at the prime factorization of the two integers, you notice the two numbers have no common prime factor. In other words, the only common factor of 4 and 7 is 1. For two numbers, if the only common factor of the two numbers is 1, we call the two numbers mutually prime. Mutually prime means so I can write this as two numbers are mutually prime if they have no common factor except 1. 1 is not a prime number. So two numbers are mutually prime means the two numbers have no common prime factors. 4 and 7 is this case. This is the special case number 2. In special case number 2, the GCF of the two numbers equals 1 always. Because as the two numbers are mutually prime, the only common factor is 1. Of course, the only common factor is the greatest common factor. The GCF of the two numbers is 1. I hope you can repeat this part from the video a few times to remember special case number 1 and special case number 2. It works very well. Would be very useful for you to finding GCF for given two quantities. Example 4, let's see how do we find the LCM of two integers. LCM stands for least common multiple. So in this case, we are looking for the least common multiple of 30 and 36. I have a 3-step procedure for this problem again. So let's see how does the 3 steps work. Step 1, prime factor both numbers. The first step is the same with earlier when we look for GCF, right? So we have 30 equals 2 times 3 times 5. 36 equals 2 times 2 times 3 times 3. Step 2 would be different. Step 2 and 3 is different. Step 2, bubble common factor using one color and leftover factors with a different color. With a different color. So here I'm going to use the color of red to bubble the common factor. And on the right hand side, in the prime factorization of the two integers, besides the common factor, we still have some leftover factors, right? For example, 5, 2, this 2, and this 3. Yeah, that's what I mean when I say bubble common factors use one color and the leftover factors with another a different color. Step 3. Multiply all the bubbled factors. And when it comes to common factor, only copy it once. Copy it once. Okay, let me explain what do I mean. So we have those numbers, those factors bubbled, and LCM of 30 and 36 would be a multiplication, a product of all the factors that you bubbled. You have 2, you have 3. Those 2 are common, right? Yeah, we do have 2 2s in the first bubble, in red, and 2 3s in the second bubble in red, but we only copy them once, 2 and 3 here. And we also have the 3 green bubbles. We have 5, 2, and 3. So those are the leftover factors in the green bubbles. So basically you're gonna copy all the bubbled factors in a multiplication. But when it comes to the common factor, you only copy it once. Let's see what do we have. The product of 2, 3, 5, 2, and 3. They multiply together, we have 180. This is 30, 90, 180. So 180 is the smallest common multiple of 30 and 36. So one thing we want to be careful is when we look for GCF, even GCF, the first word is the greatest. GCF is a smaller number. For example, GCF of 30 and 36 is 6, right? The GCF is a smaller number, smaller than 30, smaller than 36 in this case, because it's a factor of both. It has to go in both integers. Even GCF, the first word is the greatest. Similarly, least common multiple, the first word is least. But when we look for least common multiple, we are looking for a bigger number. In this case, the least common multiple turns out be 180. It is bigger than 30, is bigger than 36, right? So you need to be aware when you are looking for GCF, you are looking for a smaller number. When you are looking for LCM, you are looking for a bigger number. The number has to be a multiple of both of the 2 integers, but it's the smallest common multiple of the 2 integers. Again, you might be able to identify the least common multiple for 2 numbers just by looking at them for some of you. But this procedure, if you apply the procedure correctly, you could always get the correct least common multiple. Example 5, find an LCM for the following 2 pairs of numbers. The first one is least common multiple of 10 and 30, and you actually might already identify this as a special case number 1, right? 10 and 30. 10 is a factor of 30. 30 is a multiple of 10. Do you remember what's the GCF of 10 and 30? GCF is 10, the smaller number. LCM is the bigger number. 30 is the smallest multiple of 30, right? 30 is the smallest multiple of itself. 30 is also a multiple of 10, triple of 10. That makes 30 the smallest or least common multiple of the 2 integers. So here we have special case number 1. The 2 integers, the smaller one is a factor of the bigger one. The bigger one is a multiple of the smaller one. So the GCF is the smaller number. The LCM is the bigger number. You can put them together to remember. Compare the 2 cases. Number 2, least common multiple of 4 and 7. Yes, that's the special case number 2, mutually prime. 4 and 7 are mutually prime. Remember, If two numbers are mutually prime, then their GCF is 1. And what happened to their LCM? Their LCM is going to be their product. 4 times 7, 28. Let me explain. 4 equals 2 times 2. 7 is 7, right? Since they have no common prime factor, we don't have anything to bubble with the color red. We have this green, this green, this green. So by the procedure, the least common multiple would be the product of all the factors. And that is 4 times 7, which is 28. Or you could just remember, if two numbers are mutually prime, GCF is 1, LCM is their product. For mutually prime, I want to see something here. We can look at some cases. We have 4 and 7 is an example we used earlier. We can look at 3 and 5, and 4 and 21. So I want to explain mutually prime a little bit more. Two numbers are mutually prime doesn't mean both of the numbers have to be prime. If two numbers are both prime, like this case, 3 and 5, then of course they are mutually prime, right? In this case, GCF is 1, LCM is their product, 3 times 5, 15. Or one is prime, the other is not. 4 and 7, 7 is prime, 4 is not, right? But 4 and 7 are mutually prime. 4 and 7 are mutually prime. The GCF is 1. LCM is their product. 4 times 7, 28. In this case, 4 and 21, neither of them is prime. 4 is a composite. 4 is 2 times 2. 21 is also composite. 21 is 3 times 7. But they are mutually prime. So mutually prime does not mean both of the two numbers have to be prime. It could be this case, one is prime, the other is not. Or this case, both of them are prime. Or this case, both of them are composite. Yeah, so we do have to prime factor the integers to see if they have common prime factors or not. If they have no common prime factor, then the two numbers are mutually prime. That's the special case number 2. In special case number 2, mutually prime, two numbers mutually prime, GCF is 1, LCM is their product. Special case number 1, GCF is the smaller number, LCM is the bigger number. So in this video, we covered how do we find the GCF and LCM for two given integers. Thank you guys for watching.